Hello and welcome to my Nintendo 3DS animation video. In this video I'll be showing you how to organize models for animating in your own programs. So first off, let's go over the topics I'll be discussing. So first off I'll talk about how to create and prepare your 3D actors in Blender. I'll show you the models a moment. So here are two game actors, if you like. We have Mario here, and we have NES style Goomba here, and they are organized in such a way that will make them easy to animate. So I'm just clicking on the various parts of them here. If you think of like Lego characters and how they sort of connect together, it gives you an idea of how you want to kind of organize your models. So the Mario model here is based off of a model from the N64 from the Smash Bros game. This model here is kind of based on a model from the DS. Obviously there is this skin texture I've used here, and I've also slightly altered things for this Goomba here. Obviously this Goomba no longer is used in any future sort of Mario things. So these are the models I will be animating. First off I will show you the demo, and then I will show you the base models that I got, where I got them from, and then what I did to prepare them for animating. So first off, let's have a look at the demo. So I've loaded up the emulator here. Here we go. So we have Mario walking away from us, and then we have Goomba walking there. Using the D-pad you can rotate Mario around there, move him forward and backwards. And then if I can just get the right buttons here in the emulator, so you can see using the left and right buttons I can get Goomba to rotate there, sorry. And then I can change Mario's animation. Okay, that's Goomba's animation. So you can have him walking and then have him dying. And then let's find Mario's a minute. There we go. So that's, if you look here, you'll see this is the his state. So that's him jumping, that's him falling, that's him dying, and that's him walking again. So those are the current animation states. And then all animations have two frames. So you have like a start frame and an end frame. And then this number here is the blend value between those two frames. So when the blend value is 0, it is all the first frame. When the blend value is 1, it is all the second frame. Each frame consists of the various parts of your actor being rotated in a set direction. And then what we actually do is between each frame, so we'll have a start and an end frame, and then the actor parts will have different rotations for each of those frames. And what we're actually doing is blending the rotations from one frame to the other. which is a nice way to create a seamless animation, and it works well. In this video I will only be showing how to animate. The next video I will actually show you the animations working in an actual game demo. So that's what we'll be doing in this video. So now what I will do is I will first show you where I got the base models for these from. So the easiest way to get there is type in Spriter's resource. And then if you look down here at the network section here, you'll see we have sounds resource, textures resource, and the models resource. So if you go into the models resource and then select the console you want to work with. So the content here for my actors is from the N64. And so first off, I tried Super Mario 64, but there was lots of stuff in that model. And it was overcomplicated for what I needed. So I then looked at the Smash Bros models, and I downloaded the Mario model from here. So if you download this, you will end up with a file that looks, so it'll be like a zip file first off. So where are we? As you can see, I've had a look at a load of different characters here. Basically you can download these models and use them as like base models to kind of build off of, and also to see what detail was actually put on these models in the first place. So note here that these are all from the N64. So in our Smash Bros file, when you unzip it, you will be presented with a load of different stuff like this. So lots of this is will not be needed. And then the key thing to note here is the model types. So these are .obj files, which means they are wavefront models. Some other model formats you can find are .dae, which are collider models, and there are .fbx. The DAE and the FBX usually have like bones connected to them. So I will create a new project moment here. Select everything and delete there, and then we'll go into modeling here. And make sure that the cursor is at the world origin, which should be at 0, 0. And if you press N here, this will bring up this toolbox window here. Now what we'll do is we'll import an OBJ file here, and then navigate to where you downloaded your model. And then select your model. I'm not sure whether this one actually loads or not. No, it doesn't. I think it was one of the others here. Let's try this one. Here we go. So if you zoom in, and then you see what we have here is one solid model. Obviously this will be no good for us. And then you'll see that it kind of looks slightly different than what I've got, or what I've created here. And the reason for loads of this is what we need to do now is we need to split this up into segments. So the easiest way to do that is go into edit mode, and then what we need to do is we need to select faces here in edit mode, and we need to select mesh parts and then separate them from the group. So if you select a face here and press L, in fact let's go to this flat shading here, and then hold down shift, and then we will also select the whole arm there. So we've selected the arm and the hand there. So by pressing L, that selects all the faces linked to that like mesh object. Then right click and then separate by selection. Now what you'll see is that another group has just appeared here in the collection part here. This is the arm here. So what we need to do now is you need to do that for the rest of the parts. So what I'm selecting here is the nose, the face, the ears, the hair, and we'll also select all of the hat as well. So this will then be grouped into a new object. Now if I go back to object mode here, you'll see that we have this here, so I would call that Mario head. Now if we go into item here, one thing to note here is if I go into front view, you'll see for some reason there's a rotation on here, so we need to get rid of that. So if you press Ctrl and A and rotation, that will remove that rotation. And then we can, as we are looking straight on, I would say that's the right arm from this view. And then we'll also need to remove the rotation from that as well. So I would go through the model, separate all the bits off, and then you will end up with what I had to begin with. So once you've split everything, what you'll then need to do is make sure your model is orientated directly above the cursor here. So one thing to note here, there's the 3D cursor there. So when you sort of set everything up, you need to make sure that everything is kind of positioned above here. I'll now go back to my models that I created and give you more of a talk through of it. So another thing to talk about, what I did as well, is this model here only has one texture, whereas you saw from, let's quit this. So in here you'll see that there are loads of different textures here. This would be overly complicated to have all these different textures. So what I did was I created one texture So I'll just navigate to the project to show you a moment. So what I did was I created all of the parts we need and then just painted them in one large texture here. So we have the hat there, the face here, and the body here. So another thing that I also did, when you work with these and when you're modeling, so unlike the other model, the if I just select the nose a minute, so this the head part, you'll see that the head is kind of symmetrical there. Sometimes when you're sort of texturing, it's easy just to delete half of it and then just work with one half, get that textured, and then use a mirror modifier. And then when working with the arms and the hands, just use one arm and just use one leg, and then once you've textured that properly, then just duplicate that. I'll show you what I mean now. So I will remove this here, and then what we've got here is the head there. So what you can do is, if we separate that a moment, and then we'll hide everything else. So let's say we want to retexture this face here. Now the easiest way to do this is going to be to if you press 1 to get to the front view here, and then press Shift and Z, we can now sort of see through everything. And then what you want to do is select half of it and press X and then delete faces. And then what you've got left there is half a head there. So then what you can do is organize texture mapping of just half of it. So if we go into the UV editor here, so then we could tweak this if we wanted. So then when we're happy with that, we select our model here. So one thing to note is that the Mario character is actually orientated away, facing away from the camera. So from the front view, he's kind of looking in the same direction as the camera. So if we use the back view here, this will show us him from the front. And then what we want to do is add a mirror modifier. Make sure it's on the X-axis, flip X, and also enable clipping. So now, as you can see, he looks slightly different there. So this allows you to use halves of images. I decided to leave the full hat in view as it was difficult to kind of get working. And then once you have all of that set up, then you apply that and go into edit mode, select vertices, select all of them, and then merge by distance. So one thing to note that's happened here is we have a dysfunctional face. So we will need to fix that now. So what we'll do there is merge at the center there. And then we'll do the same here. So I'm pretty sure we've still got a hidden face there, so let's get rid of that one. Okay, so we'll repair that face a moment. So what we should have done here is split these. Anyway, I'm digressing here. The key thing to remember is once you've kind of got everything working, in fact what we'll do is we'll do that again here. So that's how you would fix that. What I did there was I extruded another vertex. So what you'd have to do now is you'd have to make sure that these are all aligned on the x-axis. So if you scale x by 0, that will fix all of these. And then when you carry out a mirror modifier, you need to make sure that the model is actually centered. So if we do that again now, in fact we'll fix that, I'll quickly fix that face there. So the easy way to sort of fix that one is we'll just scale it by 0 and then move it to a hair color. Now you can see it's the same colour as the rest of the hair there. All I did for the hair was I just dropped it on the moustache there. Select all of them and scale them to 0 and then put them actually on the sideburn there. And then we'll add another mirror modifier. And that's the new head there. I'll reload that, I don't want to save any of that. So once you've got your model textured and you've got all your parts labelled like I have here, the next thing you need to do is to sort out the center of rotation or the origin of each of these model parts. So if I hide these others a minute. So the way to do that is first make sure that you have the cursor to the world origin here. So that cursor there is at 0, 0, 0 in the world. So what I did there was you have a number of different options how you can kind of set the origins for your model parts. So if we go into edit mode, one way you can do that is you can select an individual vertex. So you'll see here we kind of have a chin there. And then if you right click and then go on to snap vertices and then cursor to selected, that didn't work. Why is that not working? There we go. Then if you press tab and come back to object mode and then right click, then you can go on to set origin and then origin to 3D cursor, and then that will set the new origin of your model part. So for the head you kind of want this maybe back a bit further so it's kind of center as if it was like a neck. So one way you can do that is with this window up here. So if you press N, that toggles that in and out. Go to Tool. Okay, is it View? Yeah, View here. And then what you'll see here is these values here are the cursor position in the world. So we don't want the cursor to be, we want the cursor to be at 0 on the x-axis. So if we rotate round here, and then if we look at the side, so you'll see here that we need to bring this back. So we can do that so you see when I change these values here, this is making the cursor move here. See that? So that's too far. That's looking probably okay there. If we bring the Z, so you see here the Z axis here, so the positive Z's going up. That's too much. That looks about right there. So if we set the origin there, so you now see the origin for the head is now there. So if we go to item here, and then if we rotate the X axis here, yep, that looks fine there. So what you'll need to do is have your actor assembled, and then click on each model part, and then do the same, set up the origin to where you think will be a good point for that model part to rotate around, as that will be where we will be basing our animation rotations from. So you need to do that for all parts. So you've got the head there, see the body there, and then the legs. As you can see, they're at the top there. Then once you have these all set up, go through each model part and make sure there are no rotations on them at the start here. Also make sure the scale is 1. So I'll show you a quick example now. I'll delete this arm here. So say, well, I'll do the same for the leg as well. So we've got one arm and one leg, perfect, how we want it. So now what we need to do is we need to create like a one for the other side. So what you can do is press Ctrl and C for copy, and then Ctrl and V, and G and X to move it. Now what you can do is you can mirror it on the X axis, and as you can see here, the origin is already set up correctly for us. However, when you click on this model, you now have a negative scale on it. So that is something that you'll want to remove, because what this means is that the model is actually inside out at the moment. Or rather, the normals are inside out. So you can see this if you go into face orientation and click this. Everything blue is where the normals are outside. However, this has a negative scale. We need to remove that. So if you click on the object, press Ctrl and A, and click on Apply Scale. We're now back to 111 on our scale. However, you can see here that the normals have now flipped. So to correct that, go into Edit Mode, select all, then go under Mesh, onto Normals, and recalculate outside. Now this is back to blue here. So now all we need to do is reposition this onto our model. So if your model is orientated over position 0, 0, 0, so I'll put the cursor back to the world origin here. So our character should be centered over this. So you'll see the location of the right arm is 0.1 by 0.47. So we should be able to do minus 0.1 . Now, these are basically, you can think of these numbers here as basically, these will be offsets from the actual actor's origin. So what I've done here is I've positioned the actor so it is above 0, 0, 0, which is the world origin. So all of these, I'll do the leg now. So Control and V, GX, and then we'll mirror that on the X-axis. Again, you'll see we have the negative scale. We need to remove that. Control and A, scale. Go into edit mode. Make sure you're on faces. Select all. Mesh, normals, recalculate outside. Then come out of edit mode back to object mode. We now need to reposition our leg. We also need to rename it as well. So if we look at the existing leg, you'll see we have 0.09. So if we go negative 0.09, it should all be in place there. So that's a quick way to set up arms and legs from just one of them. So now what we need to do is we need to position our model correctly now that we have all of these rotations here. So if I bring in a cube here a moment, and I'll explain why. So if create a cube and then put that cube at the center, make sure the cube is all dimensions 1. And the reason for this is you want to kind of consistently scale everything in your games so that everything is in proportion to everything else. As this is going to be a platform game, we kind of want our character to be positioned in such a way when we export it to work with platforms and anything else. So what I do is I create a 1x1 cube and I make sure the characters are orientated so they would be like standing on that cube. So you always want the cube underneath the world origin, and then the parts of the whole actor above here. Now what we need to do is we need to go through and we need to make notes of the offsets here of each part. This will be the local offset of this part from the world position of our actor in whatever game we are making. So all you need to do is to create a new sort of text document. And then side by side everything here. So we want our actor offsets. So we've got a head, a body, left arm and a right arm. and then the same with legs. Obviously, if you had a more complex actor you were working with, then you'll need to do the same for every limb or part from there. So in the game, the position of our actor will be basically below them and in the center, and then all of these parts will be offset from this position by these amounts. So the head, as you can see here, we have 0. Now, one other thing to note as well is, if you've worked with 3D before, then you'll be aware that Blender for some reason has the Z and the Y axis flipped around. In all other 3D, the Y axis is up and down and the Z axis is forward and back, whereas in Blender for some reason they decided to have the Y axis as forward and back and the Z axis is up and down. This also has the X and the Y rotations flipped around as well, so when you record these values, record Y and Z the opposite way round. So Z for the head here is actually Y in our game world. So another thing I would do as well is try and keep this to maybe 2 decimal places after the 0 if possible. So we can probably just put that to 50 without much sort of hassle there. So remember, this is the Y axis here, so we've got 0.5 on the Y. So can we get away without that? Probably not, we'll leave that one. So this is the Y is obviously the Z axis here. So go through and then record these values for all the body parts, and then I'll show you what I have for that. So if I open up this one here, so what you'll see here is I've created an array here for the offsets. So the value here is totally different here. So if I put these numbers here into here, what we have is 0 on the X, we have 0 on the Y, and then we have 0.52 there. Obviously this looks quite different on this model here. That's because I've tweaked the origin in here. So I will now reload this to remove all of what I've just done there. So now these values here basically match up with these here. So go ahead and note all these down here. It's probably easier to just type them out in like this sort of format already here. So that's the start of things here. So we've set the offsets for our character here. So now let's get into creating animation frames. So as I said before, all of the animations are basically the various parts being rotated. So what I will do is I will create a custom animation here, and we will plug this into the code. So what I'll do is I'll have him raising both of his arms up. So let's see, there we go. Yep, so it's on the Y. It's on the Y axis here. So we'll go for 45 there. And then, is that minus 45? Yes, it is. And then we'll rotate his head as well. There we go, and we will also rotate his legs just for fun there. So here we go. This is our new animation for Mario here. So all these numbers here, this will represent one frame. So what we need to do now is we need to record these. So the easiest way to do that is we'll just copy that there. And then we will zero all of these out here. So what these represent here are rotations on the axes. So we can see here on the head we have minus 50 on the Z, which is actually minus 50 on the Y. And then there's nothing on the body, so we don't need to worry about that. So I might end up with the arms rotated wrong here. We might have to fix that in a moment. So we see here we have on the right arm we have minus 45 on the Y. So that's minus 45 on the Z. And then we know that the other arm will be flipped. So you see the left arm is actually positive 45. So on the left leg we have 45. So that means we have minus 45 on the other. And then we have, yep, so that's it. So this would be, let's say, call that star jump there. So now what we need to do is we need to add all of these values into each of the arrays for the body parts. So you can think of it that create sort of names for each of the animations that you're going to want. And then what you'll do is you'll create an array of rotations basically for each of the body parts. And then each of these rotations will actually represent one animation frame. And then all these values here basically add up to create one animation as a whole. So let's jump into the code. So in the title screen here, I have given all of the animation frames a name. So we will give a new one there for star jump. And then we'll add this in as an animation state as well. So what we end up with is we have a frame. This is basically a frame ID, and this is an animation state ID. So each of these frame IDs represent an offset into the various rotation arrays for the body parts. So this allows us to know which frame we need to get the data from in these data arrays, and this is just a state for our actor. So now what we need to do is we need to plug in these values here in each of the body parts, which will come together and form a new animation. So we have the head, and we have the body, whilst it all may seem a bit cumbersome doing this, the advantage you have is you know exactly what's going on here. So there we go, arm right. We have the right leg. And the left leg. So we've plugged all of those in there. Now we should be able to play that back. But first off, I will explain. So first I'll reset this a moment. So how do we export our actor now? So before we export anything, you need to obviously make sure you have all of the origins set up. It should be, all the scales should be 1.0. There shouldn't be any rotation on anything. Now, once this is all good to go, to export your actor, we need to export them from the world origin. So that means you zero every part. So if I hide everything else a minute, go through, put each actor to 0, 0 with their origin, and then export them as an OBJ file. So selection only, and then triangulate faces and keep vertex order, and then make sure you give it a meaningful name. So say Mario head, and you click export. Obviously I've already exported all of these, and Control and Z to remove the origin here. So then go through, make sure you export all of them at 00. Same again, so export as OBJ, selection only, triangulate faces, keep vertex order. So export all of the models, and then you'll need to use my OBJ converter tool to convert that into data for your model part. And then you can, so if I come into here, so then you'll end up with your head, your body, your arms and your legs. So you'll have a model for each part basically. And then you'll see I've created another source file here to contain the animation offsets. And then we have another array here for the mesh IDs. So you'll see here, these are all the mesh or models, either or you want to call them. So give every sort of mesh that you're going to use, if you bring them in this enumeration here, this gives them an ID that you can use to reference. And then you'll see here we have the arrays for our models. And then you'll see here we have the various offsets and rotations. And then there's also another array here for the mesh IDs of that actor. So you'll see here this order here, the head, body, arms and legs, this should reflect the order you have the offsets in, because obviously they will be pointing to these meshes here. And then this will allow them to be picked up easier in the AnimMesh structure, which I'll go over in a bit. So each body part will have various rotations on here, and these basically correspond to the animation frames here. So you'll see here the first one is walk 1, and then this will be walk 1 in each of the parts here. Idle is the neutral position. So you can think of this here as being the idle frame here, where there's no rotations on anything. And that's basically what we end up with. There's no rotations on the body for Mario here, so these are all zeros. The neutral position here, if you go through and have a look on all the body parts, you'll see they're all zeroed out here. So we've got our new jump animation frame there. So now we need to plug that in somehow. So what we will do is Okay, if I called it something different. Ah, it's because I've called it start jump. So let's see if we can. So there's our jumping. Ah, I've not created a name. Let's stop that. That should have picked, and I wouldn't have picked it up. So what I've got here is for this demonstration here, I've obviously given each animation state a name. So you'll see these are the animation states, and then I have a string name so we can actually report what's going on. Not sure what would have happened if that had run. Probably undefined effects. So we'll rotate them around, jump in, fall in. Ah, it's because I've not added the okay. I'll go over all this in a moment here. Let's do that again. There we go. So that's our star jump there. So now I will explain all of this. So I will come out of this here. So I'll go over this structure now for how all this works. So as I was saying, what we need is the offset and the rotation for each of these limbs here or body parts. So what we have in code here is we have the offset position from the actual position of our actor, and then we have the rotation now. So these rotations and offsets here, these are local from this position, scale and rotation. So you can think of this position and scale and rotation in the anim model structure as being where the actor is in the actual world, their actual size, and the rotation they are facing in. The body parts themselves, they have an additional offset from this position, and they have their own local rotation, which is basically on top of whatever the actor as a whole rotation that they have. So what I have here is we have an array, or basically you can think of it as like a list of our animation parts. So in this case I've defined it as static arrays to make it easier to explain rather than having to dynamically allocate memory for these, but you could just as easily have this as a dynamic array if you wanted. Or if you wanted models with more parts in, you could just increase that number. For example, if you had like a spider or something, you might need like 12 or more parts. Which is why we have a part count variable in the anim model itself. So these position, scale and rotation are for the actor as a whole. Then what we have is we have a number which represents how many frames in total the actor will have. And then what we have is a frame now and a frame next, as we are always looking to blend between two frames. Which is why you'll see here at the start, if we wanted to plug him in this neutral position here, then at the start would be frame 1. So if I bring this up here, so you'll see frame 1 here is idle. And then the next frame could be, well, if he was going to walk off, then the next frame could be either frame 0, which is where the right leg is back, or frame 2, which is where the left leg is forward. And then you'll see here we have one texture which encompasses all of the animation parts. You could obviously have a texture in each mesh part if you wanted to have all that much detail. And then you'll see here that each anim part has its own mesh ID. These IDs match up to this array here. And then we have a blend value which is between 0 and 1. So what happens is the blend value determines which of the rotations in the frames gets the to make the most difference to the actual model part. So by blending between these two frames, you can go from so if I demonstrate here, you'll see that the x-axis on this arm is 0 here. So if we rotate it just on the x-axis, so this would be a value of 1, a blend value of 1. So if we come to the arm here, so you'll see there's the neutral frame there with a rotation of 0, and there's the next frame with a value of 67 on the X rotation. So the blend value in this case would go from 0 to 67, just as I did here. So the blend value basically uses a lerp function to blend the rotations between two frames. So once you get your blend value at 1, that's when you wish to swap the animation frames. So you would then copy the next frame ID to the now frame ID and then plug a new frame into the next frame. Then you reset the blend value back to 0. Hopefully that makes sense to you. So I will now explain each of these functions here to set up the anim model, and then why we need all these different arrays here. So to create a new anim model, we'll start with our Mario character here. In fact, what I'll do, let's see if I can do this, whether this works. So here's the function name here. This is the function prototype here. So you see it takes in the a pointer to a new anim model. So at the very top here I have two. We have Mario and Gumba. If I come back down to here. So to start off with, we need to pass in our empty anim model. We then need to say how many parts the model will have. So for Mario here, you'll see we have 6. 1, 2, 3, 4, 5, 6. And you'll see here for Gumba there's 4. If I bring him back in. No, we don't want that one. So you see he's only got 4 parts there. And then you need to say how many animation frames they have. So in this case you can see here we have 8. We could, instead of putting 8 in there, we could have just used the enumeration here. So we've got 8 there. Then what we need to pass in is a pointer to the offset data. So as you'll see here, we just pass in this array here. Then what we need is a pointer to the mesh IDs which make up our model. And you'll see I've plugged in this one here, which takes in all of these here. So the initialize function here basically takes the offsets and the mesh IDs, and then what it does is it then casts the offset data to vector 3fs. So it basically takes all 3 of those there. It then just fills in the properties of the anim model structure. So you'll see it initializes the frame now ID, the frame counts are plugged in there, part counts are plugged in, blend value is set to 0, and then it iterates over each of the of its child parts. and then it basically sets the rotation array of each part to a null pointer there, or a null. And then what it does is it feeds in the offset values from each part into the actual structure of each part in the anim model. So that basically sets everything up almost. I say almost because you kind of then need to go through each part and then give it its list of frame rotations. So this is where this comes in handy here. So you'll see we have the part IDs here for Mario here. So the head is part 0. We then need to pass it in the rotations that the head will go through. So these orders here need to be in the same order as all of this, so head, body, arms and legs, as you'll see here. Then once you've initialized all of the parts, that's when, to start everything off, you would then call the anim prep function. What this then does is it will then take the rotations for each of the start frames and plug those into the rotation now of each part. That then sets everything up with the blend value of 0. So you'll see here the prep anim here, where you pass in the frame now, the frame next, and then what we then do is we iterate over every part, and then, like I said, we take from its animation list the rotation and plug it into the rotation now. At this point we are good to draw this. So to draw this, you would call the animModel render function. I'll explain this here first before I go into the play function here. So this takes us into some new draw functions in Scene 3D here. So the new draw functions I've added in here are draw parent model, begin, draw child, and draw parent model end. And there's also some booleans here to catch what sort of a state Scene 3D is in if you're not aware of it. Because obviously we can be in 2D mode for drawing 2D tiles to the top screen, normal 3D mode for drawing normal 3D models, or in parent mode. So you can think of the AnimMesh here as being like a parent and child relationship. where each of these childs or children, which is the each animation part, relies on its parent's position, scale and rotation. So what I actually needed to do to enable the drawing of this is you kind of need to store the model matrix of the parent. So where is it? Here we go. So there's an additional matrix here for the parent. So what happens is when you call parent begin, we go through the normal transformations. You see, we only have that parent model there. So what we first do is we copy the model view matrix from the camera to the parent matrix. We then translate to the position of the parent, do the rotations and the scale of the parent, bind the texture, and then we say we're in parent mode. So then what we do is we draw every child. So the difference here is what happens is we, instead of using the view matrix, we copy the parents matrix into the model view for the child. So we basically concat, or we add additional translations, rotations for the child before we plug in the details to the shader and then draw the mesh. So that allows us to basically start from the offset of our actor each time, and the offset of the actor will always be, or should be, for this character here at the bottom there between the feet. What happens is this offset here is multiplied by the parent scale to offset it from this position, which is below the actor, and then any rotations which are on the parent is then added to the local rotations of the part. And then at the end of drawing your all of your children, you need to basically just set the parent mode to false. So those are those new functions in Scene 3D that handle that. So now when we look here, this will all kind of make sense to you here. So we create basically an empty model here, and then we set it up with the parents details here at the start. One thing to note here is that I flip the Z-axis in here. As I like everything to always be working on the positive Z-axis. inside the models themselves, but obviously I draw them correctly on the negative z-axis. So once we set all this up here with the animodels parent details, we then call model begin. Then what we do is we iterate over every part in our animodel, and then we change the model's position to the part offset. We put the model's angles to the part's rotation now. We then set the model mesh to the parts mesh, call draw child model, pass the model through, and then this just iterates over all of them, and then we call parent model end at the end here. So that's how it's drawn. Once we have all of the details all plugged in, it's very easy to use once all that's done. So let's get into the play in function here and how that works. So the animodel play, what you pass in is you pass in the animodel itself and the update speed to apply to the blend value. Now so what we create here are some local variables in here just to hold some of the animodels details. So you'll see here we have a blend value which basically copies the blend value from the animodel, and then we have 3 vector frees, start, end and result. These are used in the lerp function here, which is how things are blended. So if I open that up, so to blend between these rotations, we basically need to blend the X value with one frame with the X value of another, same for the Y and same for the Z. So we pass in our blend value, which is between 0 and 1. So 0 is fully the start value, 1 is fully the stop value. And then the destination here is basically where the results are put, as we do not want to alter the start or the stop values, which is why they're passed in as const pointers. So it's easy enough to do this. Basically what we do is we work out what the difference is from the start and stop, and then we multiply that by the blend value, and then in the destination we add this difference to the start value and pass that back into the destination here. So this just works out the difference between one rotation and the next. So that's what the lerp function does there. Like, we end up basically with either fully the start, fully the stop, or somewhere in between. So another thing that happens in the animation playback here is if the blend value ends up being less than 0 or greater or equal to 1, then we've reached the end of that animation frame. And then we also clamp the blend value to either 0 or 1. so that it can't run over. So it can either only be fully to the left or fully to the right, basically, of the 2 frames. Then what we do is we pass in the blend value back to the animodel itself. We then iterate over all of the parts, and then we take the rotations from frame now and frame next, so each becomes start and end. We then pass those along with the blend value and the result vector 3 to the lerp function. The result in vec3 that's passed back then becomes that part's rotation now, and then we iterate over all of them, and then we return whether the end has been reached boolean. If it returns true, then it means you then need to update your actual animation frames, the frame numbers themselves. So you might need to look over this a bit more or play around a bit more to fully understand how this works, if my explanation has gone over your head here. But the functions themselves, there's only a few here. I think that's probably the easiest way to get simple animations happening. So what you could also have is you could have additional offset values as well. So you've got like a rotation now. You could have offset now as an additional array, but obviously that would be more data. So you could, for example, have these are anim rotations for the head. You could have anim offsets for the head, where you could have body parts not only rotating, but you could have an additional offset. So you could have the arm maybe moving partly as they're sort of animating. And then you could have offset position now in here, and then also an array of offsets if you really needed to have that. That is, sometimes the simplest methods work best. So I've explained the animodel structure here. So all what's left to do is to go over the code in here now, what's actually happening. So setting up the model here for Mario here, so you'll see that I've given him a scale here. So the way that I think of these animodels here is you can just think of this as being like an actor. So this is basically setting up your actor here. You set up, plug the parts in, so you would kind of only really do that once at the start of like your game. Then set your texture and scale. This is just positioning them in the world and setting an initial rotation. And then I've kind of done like a hack here to set up the walk frames animation, and I'll explain that now. So this is an array of frames for the walk animation. If I bring back up this again here, you'll see we have frame 1 as the start, which is the neutral position. Then we have frame 0, which is the right leg forward. Then we go back to the neutral position, which is frame 1. Then we go to the other leg fully forward, which is frame 2. And then if we start this again, obviously we go back to 1. So this basically creates the loop of going through all of the walk animation there. So I have like a quick and dirty function here for setting up the frames at the start here. So at the start of the game or level or whatever you would sort of call it, and here all I did is I set the frame now at the start to 255. So if the frame ever reads 255, then it basically means you have to start over again, basically resetting it. So what happens at the start here, so before we jump in here, the Mario anim ID next would be 0. So the frame now picks up the first one in here. This then increments. Frame next then picks up the next frame there. And that basically starts it up. Otherwise, when you call reset, what happens is it copies the next frame to the now frame and then picks up the new next frame. If the next ID equals 4, which is past the end of this array here, then it resets to 0. And then, like I said, to start everything up, you call animprep with the now frame and the next frame, and then call animplay with 0 as the blend value. Will fully set up the actor with the frame now. This is the same thing for the Gumba reset animation here. And then there's two functions I have here for switching states. So one thing to think about is in your game you're walking along and then suddenly you press the fire button to jump or A button to jump. So now you need to think, okay, so which frame will be the start of your jump animation? So all I did here was, if the blend value of your actor is greater than 0.5, then that means you are predominantly on the next frame. So that next frame would then become your start frame. This will kind of make sense to you when you sort of play around with using the animations. You might even decide to do it differently, but at some stage you need to decide which will become your new start frame and which will become your new next frame. So for the Gumba here, we check on what the states are, because sometimes this will be the case, and others you'll just plug in new values regardless. But ultimately you will need to call animprep with a new now frame and a next frame, and then animplay with 0 as the blend value to start off. So you'll see here in Mario, we have the same thing. Sometimes we will use this other times. For example, if you just press jump, then we automatically plug in a now frame and the next frame from jump start and jump up. So for every sort of state you need your actor to sort of have, this is like an easy way to kind of do it here. And of course there's the prep and the anim play there. And there is nothing really new that's going on here. As you can see, we set the our actors' states here, and then depending on what buttons you press, you will switch states. And then to draw everything, it's as simple as that. Once everything's up and running, anim model render, and then just pass in. So that's pretty much it for this video. In the next video, I will preview both of these actors in a Super Mario Brothers style game. And I will use a third-person camera, and I will also be putting in a different shader as well, which has lighting enabled in it and uses materials. I'll also go over level scrolling and all sorts of other useful things. So that's it for this video. Got any questions or comments, then leave them in the link below, and I will catch you in the next one. Thanks for watching.